This is a video lesson for Work Energy Theorem. The essential question for this lesson is, what is the Work Energy Theorem? How does it connect energy and work? So just as a review, let's look at kinetic energy. So kinetic energy is the energy of organized motion, the ability to do work through motion. So we can see the pendulum swinging back and forth here. So as it moves, it gains and loses kinetic energy. So as it swings through the swing, it has kinetic energy. And its greatest point of kinetic energy is at the bottom of the swing. And as it reaches the top of the swing, it's losing kinetic energy. The equation for kinetic energy is K equals 1/2 m times v squared. So kinetic energy equals 1/2 times m, which is the mass, times v squared, which is the velocity squared. Let's look at potential energy. So potential energy, U, is stored energy, or the ability to do work because of position or condition. So here we see the pendulum swinging back and forth again. And so this is a good example of gravitational potential energy to start with. So gravitational potential energy, U sub G, is UG equals m times g times y, where m is the mass, g is gravitational acceleration, and y is the height. So as the pendulum swings, it's losing gravitational potential energy as it swings down, and when it swings back up again, it's gaining potential energy. So swings up, loses potential, or gains potential energy, swings down, loses potential energy. Another type of potential energy is elastic potential energy. So when the pendulum swings and hits the spring compresses and the pendulum bounces off of it and swings back the other direction. So the equation for elastic potential energy is U sub E equals 1/2 K times x squared. So K is equal to the spring constant and x is equal to the displacement. This is how far the spring is compressed or how far it's stretched, if the spring is stretched. So this is another type of potential energy. Let's look at total mechanical energy. So total mechanical energy is the total kinetic and potential energy of a system. So the equation for total mechanical energy is E equals K plus U. So E is equal to kinetic energy plus potential energy. We can expand that to total mechanical energy is equal to 1/2 mv squared plus mgy. So that's the equation for kinetic energy plus the equation for potential energy. Finally, putting everything together into the work energy theorem. We have the work energy theorem is the change in energy of a system is equal to the external work done on that system. So the external work is equal to the change in energy. So the external work is equal to the change in kinetic energy plus the change in potential energy. So positive work done is equal to positive change in energy. So positive work done is equal to the positive change in energy. And negative work done is equal to a negative change in energy. So Forces that do negative work on the pendulum Earth system, like friction, cause the pendulum to lose kinetic energy. So, negative work causes the pendulum to lose kinetic energy. So, anytime you have friction, you lose positive kinetic energy. In a clock, the counterweights, or electricity, do positive work on the pendulum Earth system, increasing the available energy. So if you have a counterweight or electricity in a clock, they do positive work on the pendulum Earth system, increasing the available energy. So they keep the pendulum swinging even though there's friction, which causes the pendulum to lose kinetic energy.